Ever wondered how important spatial temporal Kriging is in data analysis? If you have, then you're in the right place. If not, then get ready for an enlightening journey into an essential aspect of data science. Spatial temporal Kriging, it's a term that may sound intimidating at first, but it's actually a powerful tool used by data analysts and scientists around the world. It's a statistical method that enables us to predict the value of unobserved data points based on the values of observed data points. The magic of spatial temporal Kriging lies in its ability to incorporate both spatial and temporal correlations. Think of it like this. It's like being able to predict the weather at a certain place and time based on past weather patterns in the surrounding areas. But why is this important, you ask? Well, the ability to predict unobserved data is a game changer in many fields. For instance, environmental scientists can use it to predict air quality at different locations and times. Economists can forecast market trends, and public health officials can anticipate disease outbreaks. The possibilities are endless. So how does Python come into play? Python, a widely used programming language known for its simplicity and power, provides libraries and tools that make the implementation of spatial temporal Kriging a breeze. And that's exactly what we will be doing in this video. We'll guide you through writing Python code on dummy data for spatial temporal Kriging. We'll go step by step, explaining each line of code as if the real code is running right before your eyes. By the end of this video, you'll have a clear understanding of spatial temporal Kriging, and you'll be able to implement it in Python, unlocking a whole new world of data analysis possibilities. So whether you're a seasoned data scientist looking to brush up on your skills or a Python learner eager to explore new techniques, this video is for you. Ready to dive into the world of Python and spatial temporal Kriging? Let's get started. First things first, setting up the Python environment is essential. It's the foundation on which we'll build our spatial temporal Kriging code. Think of it like setting up a workspace before starting a project. To start with, we'll need a few key libraries. These are like the tools in our coding toolbox. We'll need pandas, a data manipulation library, and NumPy for numerical computations. Lastly, we'll need Kriging, a library specifically designed for Kriging. Now let's talk about installation. Using pip, Python's package installer, we can easily add these libraries to our environment. By simply typing pip install followed by the library name in our terminal or command prompt, we can have these tools at our disposal in no time. Remember, it's crucial to have these libraries installed correctly to ensure our code runs smoothly. After all, a craftsman is only as good as his tools. With the environment set up, we're ready to dive into the code. Now that we have our environment ready, we need to import our libraries. Libraries in Python are collections of functions and methods that allow us to perform many actions without writing much code. In spatial temporal Kriging, we need specific libraries to handle both the spatial and temporal aspects of our data. First off, we have NumPy, which is fundamental for mathematical computing in Python. It provides support for arrays and many mathematical functions. Next, we have pandas, a powerful data manipulation library that lets us work with structured data conveniently. Then there's matplotlib and seaborn for data visualization, which will help us understand our data better. For the Kriging part, we will use the Kriging library. This library offers robust tools for Kriging, a method of interpolating data points in space and time. Lastly, we'll import scikit-learn for machine learning tasks, which we will use for predicting and validating our model. With our libraries in place, we can now move on to the exciting part, the data. Data is the lifeblood of any analysis, and ours is no different. Now that we've set up our Python environment and imported all the necessary libraries, it's time to focus on our data. We'll be using pandas, a powerful data manipulation library, to load our data into a data frame. A data frame is essentially a table, similar to an Excel spreadsheet, that allows us to easily inspect and manipulate our data. To load our data, we use the read_CSV function from pandas. We simply pass the file path of our data to this function and it returns a data frame. It's as simple as typing pd.readcsv followed by the path to your data file in parentheses. Once we have our data loaded, it's essential to inspect it to understand what we're working with. Pandas head function allows us to peek at the first few rows of our data frame. By typing dataframe.head, we can see the first 5 rows of our data. If we want to see more or fewer rows, we can pass the desired number as an argument to the head function. To get a statistical summary of our data, we use the describe function. Dataframe describe gives us a summary of the central tendency, dispersion, and shape of the dataset's distribution, excluding NaN values. It's a quick way to understand the distribution of our data. Now, let's talk about visualizing our data. Visual inspection of data is probably the most important step in data analysis. Matplotlib, a plotting library, allows us to create graphs and plots to visualize our data. For instance, we can use a scatter plot to visualize the spatial distribution of our data points. We can create a scatter plot by calling pultscatter and passing the longitude and latitude columns from our data frame. After that, we call peltshow to display our plot. This gives us a clear visual representation of the spatial distribution of our data points. Now that we have a grasp on our data, it's time to prepare it for our Kriging analysis. Pre-processing is an essential step in any data analysis task. Before we can apply Kriging, we need to ensure our dataset is in the best possible shape. This involves several steps, including handling missing values, normalizing the data, and splitting our dataset into training and testing sets. Let's start with missing values. It's quite common in real-world datasets to have gaps or missing information. In Python, we have several strategies to handle them. For instance, we can use the fillNA function to replace missing values with the mean, median, or mode of the data. Alternatively, we can also use the dropNA function to eliminate rows or columns with missing values. The choice between these strategies depends on the nature and size of our dataset. Next, we normalize the data. Normalization is the process of scaling individual samples to have unit norm. This is a common operation for machine learning or in scenarios where we want to compare measurements that have different units. In Python, we can use the standard scaler or min-max scaler from the sklearn.preprocessing module to normalize our data. Finally, we split our dataset into a training set and a testing set. This is crucial for evaluating the performance of our Kriging model. Typically, we allocate about 70 to 80% of the dataset to the training set and the rest to the testing set. In Python, we can use the train_test_split function from the sklearn.model selection module to perform this split. Remember, pre-processing is not a one-size-fits-all process. It's a series of decisions that depend on the specifics of your dataset and the problem you're trying to solve. But with a solid understanding of these steps, you're well on your way to mastering data analysis in Python. With our data pre-processed, we can now move on to implementing spatial temporal Kriging. Finally, we arrive at the heart of our task, implementing spatial temporal Kriging. After all the groundwork we've laid, it's time to bring it all together using the PyKrig library in Python. Firstly, we'll need to import the necessary classes from the PyKrig library. For this task, we'll require the ordinary Kriging and ordinary Kriging 3DE classes. Let's go ahead and import those. Now, on to the actual implementation. We start by creating an instance of the ordinary Kriging class. We pass in our spatial and temporal data along with the semi-variogram model we want to use. For this example, let's go with the spherical model. Next, we call the execute method on our Kriging object. This is where the magic happens. The execute method performs the Kriging calculations and returns our interpolated values. We'll pass in the grid points at which we want the interpolation to occur. The result is a tuple with 3 elements: the Kriged grid, the variance grid, and the actual Kriging instance. We'll store these in variables for further use. To visualize our results, we can plot the Kriged grid using Matplotlib. But remember, the beauty of Kriging is not just in the visual output. It's in the statistical rigor that underpins it, in the way it allows us to make informed predictions about unobserved locations based on observed data. Finally, we must not forget to check the quality of our Kriging model. We can do this by comparing our predicted values with the actual values at known locations. This will give us an idea of how well our model is performing. And there you have it, a complete implementation of spatial temporal Kriging in Python. We've taken a deep dive into the world of geostatistics and come out the other side with a powerful tool for spatial data analysis. Remember, the journey of learning never ends. Keep exploring, keep learning, and keep coding.